They were right. It
Yeah, I
is
know,
bright like the sun.
It'll keep me awake, though.
How's everyone doing? Good, good. So we had a question about the background of the folks that are in the audience. How many folks are data scientists? How many folks are consider themselves technical? How many folks are more kind of higher level, want to get a sense for what's going on in the space, not super deep? Okay, so we can walk that line.
Yeah.
Do both. Awesome, awesome. Nice. I love it. I love it. So, again, I'm Sam. This is, I see no reason not to make this an intimate discussion, so feel free to move forward if you'd like. We're talking about visual search, primarily in e-commerce, but we'll talk about some other applications as well. Stephanie is a senior product manager for recommendation systems at Pinterest, and Dan is the head of data science and machine learning at, that's not us, at Wayfair. And we're going to get started by having each of them spend a few minutes talking about their companies, what they're doing in the visual search space, talk a little bit about kind of how your chart of your teams and how you're organized, that kind of thing.
Sure, I can start. Yeah, so I'm Stephanie. I'm a product manager for recommendations. And at Pinterest, a lot of recommendations revolve around e-commerce and computer vision. So this is like basically the perfect panel for me to be on. In terms of just giving a little bit of context. Oh yes, that is us. Give you a little bit of context about Pinterest. We describe ourselves as a visual discovery engine. And what that means is really just users are finding, exploring, discovering ideas that they love through visual means, right? And that often is images, it's more recently videos. And what that means for us is computer vision is like a huge part of Pinterest, whether that's being a signal in the models that we use across all recommendations across Pinterest, in our home feed, in our search. All of these recommendations use computer vision signals. But we also have very specific features that are focused solely on computer vision. If you guys were at the previous panel, Chuck talked a little bit about those features, but it includes something like visual search, where we show you visually recommended content based on the image, potentially a video in the future, or camera search, where you can do that in real time by taking a photo or uploading a photo from your camera roll. Transitioning a little bit, I work on computer vision and shopping. So like shopping has become a huge part of Pinterest. It's obviously a great opportunity. It's a big use case. People are shopping even more than they used to on the internet. And so Pinterest has moved towards focusing on that. And one of the things that is basically at the intersection of e-commerce and computer vision is this feature we call Shop the Look, or specifically we're automating Shop the Look. And just for context on that feature, because that one wasn't talked about very much, we actually have a feature that allows creators or third-party companies to tag images with products that they can purchase. We made that feature so that we could collect the data so that we could ultimately automate that one day. And that's what we're doing now. And so we have launched automated Shop the Look for home decor, and you can actually see that live in the app today. And we're working on fashion next. And that is probably going to be the primary feature that I would talk about on this panel, but I'm happy to talk about any of the computer vision features or even shopping features around shopping recommendations. And yeah, I sort of work on all of these different things with different teams. There's a computer vision team, there's a shopping team, and then there's like the intersection of those, which is this feature called Stella, or Shop the Look Automated.
Cool. Awesome. Dan?
Yeah. So hi, guys. I'm Dan. Thanks for your time. I'm guessing it's been a long day for most of you, so appreciate the time and attention. I'll give a little context on Wayfair's data science team, because I'm guessing most of you are familiar with the brand, but some things you might not know. We're a pure play e-commerce company focused on home furnishing and decor. We've been growing at roughly 40% year over year, $7 billion trailing 12 months revenue, so probably a larger company than you might have imagined. We build a lot of our own technology. So we have around 2,000 engineers and data scientists more engineers and data scientists, but it's a pretty large effort. In terms of my group in particular, we're around 150 data scientists strong. We work in all sorts of different areas in the business. So we have folks that are embedded in marketing, storefront, personalization, computer vision, merchandising, and so on. So you name the technology or the application, we're probably working on some aspect of it. And for sure, a big piece of what we're doing is focused on computer vision and visual search, just the general idea of how do we incorporate imagery into all the machine learning models that we're building, how do we get that feeding into the actual user experience. So on the visual search side, I double-checked this before the panel. We started on it around 4 years ago. So by no means a pioneer, anything like that. But we definitely were early adopters of the technology. And when you think about Wayfair's business, that actually makes a lot of sense because we're a highly, highly visual vertical. And then when you look at what our customers struggle with, we have a really, really deep catalog. And it's not always easy to articulate what you want. So think about the sofa in your home or the table in your home. Like, I bet it wouldn't come naturally to say, like, what are its features, what style is it, what color is it, and so on. So we really need to be able to do as much as we can to take what the customer has in their head visually and ease the shopping experience for them. So in terms of the visual search experience on Wayfair, it's pretty standard. We let the user take a picture or upload one. We apply object detection, which is then going to find the pieces of furniture in the room. Given the thing that they want to search, we generate an image embedding, and then we find similar looking things in the catalog based off of that. So it's pretty standard. In terms of the tech behind it, I'm happy to go into more details, but to give you like a relatively high level of it, we do a lot of things that are standard within the visual search space. So we're using Inception ResNet, which is a standard package. We're using techniques like hard example mining, contrastive loss, and so on. I'd say what sets us apart from others that are doing visual search, Wayfair has a ton of proprietary imagery that we take ourselves. We have a lot of user-generated content that's labeled. We get a lot of imagery from suppliers of the same product in different contexts, which is fantastic for a visual search sort of application. And then even beyond that, we have a team that basically curates 3D models, and then we're able to use those to synthesize scenes. So we can create synthetic training data sets in areas where maybe we don't have the imagery from suppliers or we notice that the model's underperforming. We can create that data set in a relatively easy, low-cost way. And the last piece, similar to how it sounds, it's at Pinterest. Like, we're not just a visual search oriented, rather we're not just oriented on the visual search use case. We're taking the underlying model and using that to help power personalization and the sorts of recommendations that we're generating. We're using that to figure out how do we curate the catalog. So for us, it's visual search, but then even beyond that, we've been able to see a lot of really good results. The last thing I'll kind of leave you with for the intro, it's been 4 years, but it's been a really great investment for us as a company. And frankly, it's been a big effort outside of just the data science team. So it's data science plus good number of PMs, creative folks, engineers focusing on the storefront. So it's been a big team effort for us.
Awesome. So when I talk to folks that are working on real world projects in this domain and most in machine learning, the data is always the biggest challenge. Stephanie, you alluded to where some of the data in your use case comes from. You had users manually tagging these images, and then you using that as part of your training data set. But can you walk us through the data pipeline and where your ground truth data is coming from? And I'll ask you the same, Dan.
Yeah, so we basically developed like a very baseline solution to computer vision, or like visual search, essentially. And we actually built an internal tool that allows you to map a scene, so multiple objects, maybe shot in context, to object detection, and then from that object to visually similar things. We actually didn't start with creators manually tagging. We started with sending those to experts to human eval, and those experts were trained and they're steady, and so like we have very high confidence in the quality of that data. It's only more recently that we started using the data from these creators, and now we're sending that data through to the same human eval for the high quality sort of check. And so we have hundreds of thousands of examples, whether it's from scene to object for the object detection model, or it's from object to category to understand that object better, or then from object and category to visually similar recommendations. And so like getting all of those labels, again, it's on the order of hundreds of thousands that we're training with today. All of that sort of went through human eval so that we know that it's super high quality. We've been very lucky that we can get that much data. Obviously, like it's hard to do that at scale. Like you said, one of the challenges is not only getting data, but knowing like what data to get, how, like what level of granularity should we get? Should we have bounding boxes? Should we have categories? What specificity of the taxonomy should we have to understand this? Like, yes, we know it's furniture, but is it a couch in the home decor example? Like how specific should we get with these labels, I think is another really big challenge that we are still iterating through. And we start with like, let's just get the most level of granularity possible and we'll figure it out from there.
Yeah.
Because
did you develop your own tooling for labeling and bounding boxes and the like?
Yeah, so the internal tool we built, we actually gave to these like human eval experts that we hired through a third-party company, and we gave them that internal tool to essentially like they can drag and drop where the bounding boxes are. They can tag with, we use the Google product taxonomy for the categories that they're going to label. Then they can look through all of the results, whether that's through the baseline visual search, which has gotten better and better with all of the training data that we've gotten, or even recommendations from like manually tagged curated content. And so that internal tool has really helped us make sure like the quality of training data is really good. So I'd say like what data, the quality of the training data, and then like how to do that at scale. All three of those have been challenges that we've been trying to tackle.
Mm-hmm. Yeah, and on the Wayfair side, the challenge is probably less in terms of having an image that's labeled with a certain product and then having another image of that same product because we're explicitly getting that from suppliers.
Okay.
Or when we get it from users, it's associated with a review or something like that. The two big challenges we did run into, one was on the object detection side where that's not what we're getting from suppliers. So we had to build a UI that we could expose to a third-party team and basically have them just tag lots and lots of images so that we could train that algorithm to understand where the different pieces of furniture were in the room. I would say beyond that, though, like an even bigger challenge is having a model that generalizes to user-generated content. Mm-hmm. So the two sources of truth that I mentioned, that what we get from the supplier, what Wayfair is producing itself, those are really pristine images. And they're taken in like idealized context. It's, a room designer creates the room, the lighting's great, and so on, versus like when the user's interacting with the feature, we're getting a blurry image where, like the angle's all screwed up and that sort of thing. So it's a little bit of a balancing act to make sure that you're learning what you can from those more pristine images, but you're building a model that still generalizes to sort of the fuzzy stuff that you get when users are actually interacting with the feature.
Mm. And so when you're building this model, are you optimizing for some objective similarity metric or something that's more user-driven, that's like their propensity to click or buy or something like that based on what you're presenting them?
So it depends on the use case. For pure...
Same.
Yeah, and I can give a couple examples to show what I'm talking about. So for like pure visual similarity, so that where the task is given a thing, I want to find other things that are like that. We're basically training the model to know that we want those two things as close together as possible, and then we're also feeding it examples of things that shouldn't be close together. And really like that's the metric we want: things that are labeled the same close, things that are not further away, and that's based on sort of well-defined labels. Mm-hmm. The one where it gets a little bit fuzzier and where we are using user feedback is we have similar models that get at product substitutability. So it's not just a notion of like, does this thing look exactly the same? It's like, if you had this product and this product, would you be equally happy buying them? And then to get at that notion, we're basically exposing to third-party taggers the image and then information around like the material, the price point, and that sort of thing, and then having them rate on a scale the level of closeness that they're seeing. So it's In that case, where it's like a little bit fuzzier of a notion of what we mean by similarity, like we're going out of our way to collect that information.
Mm-hmm. Okay. So Dan, you gave a little bit of a technical overview, and it sounds like some of the underpinnings of the automated shop the look and the visual, your shop with photo are similar. One of the kind of core technologies here is like convolutional neural nets, and you mentioned ResNet. To what extent are you taking advantage of transfer learning in your use cases? Stephanie, in your case in particular, you started with home decor, right?
Yeah.
And then the next step is fashion, which suggests that even within those two domains, there's not perfect transferability. So maybe you can speak to that aspect of transfer learning, and you can speak to the models themselves.
Yeah, I mean, so one piece of context that's probably helpful, and we're publishing a paper on this soon, is we actually, for our embedding model, which is really how we tell if something is visually similar, we have a unified embedding across almost all of our use cases, so across all the different features that I mentioned, including visual search and camera search and this shop the look feature. And that's pretty different, I think, from like most companies. Like they'll build embedding specific to their use case. And the nice thing about that is we're getting a whole bunch of transfer learning from like the different use cases that it's training on, and then supplementing the training data with specific labels. So in the case where we started off with just essentially a visual embedding, just learning embeddings based on the pixels themselves. When we introduced training data for Shop the Look, which was like 300,000 scene to object recommendations, we wound up increasing engagement by like 72% and like relevance by double digits. Basically, like there is a whole bunch of learning that's overlapped, but we want to be like adding in new training data is really the difference. Like as soon as we get new training data, it's going to make every part of the model better. So when we added that for Shop the Look, it was obviously very engaging for Shop the Look, but it also wound up having double-digit percentage increases on visual search itself and a single-digit increase in camera search, the blurry images that you take. And so just by adding these training data examples for this like completely different use case, because we use it across all of these use cases, we were able to improve the use case for the camera search and visual search, which was really awesome. So I would say the thing with home decor and fashion specifically is we don't do well in fashion yet. Let's add more data around fashion. Like specifically, we're actually starting with like a very specific use case of like dresses. And then when we add that training data, it's going to probably improve home decor and hopefully make dresses at a level that makes a lot of sense.
And then around the question of like how often do we transfer learn versus like build our models from the start and that sort of thing. Very early on, we did benchmarking of if we weren't using the off the shelf and transfer learning on top of that, or versus like building it from ground up using just Wayfair data. And frankly, it was no contest in favor of starting with off the shelf and then transfer learning off of that. And how we got there was basically looking at back testing. So saying like if we had built a model purely off of Wayfair data versus using some of the stuff that's publicly available, how successful would the model be in practice? And yeah,
so it's not even an issue of cost to train the model. It's absolute performance. You just do better starting from the pre-trained models.
That's right. And like I'm not going to be great with the order of magnitude exactly, but like when you compare the order of magnitude of the images that are used to create some of those baseline models versus what Wayfair has available, we have a lot that's available. We don't have nearly that much. So it's useful to use those because like they'll do a good job at understanding some like basic common things about imagery, like things around the edges and general shapes that are appearing in them. And then we're able to insert ourselves at a later part of the network and then have it learn more of the idiosyncrasies around the products that we're selling.
Okay. Stephanie, you mentioned embeddings a couple of times. That's probably one of the core technologies that underpins visual search. Has that been covered earlier in the day, or would a brief overview of embeddings be useful? Yes, cover it. All right. Who wants to take on a 30-second overview of embedding?
Just what embeddings are. Okay. Let me try to think this. So what embedding is, if you think about the problem of like comparing two images in the abstract, and you said, I want to say quantitatively, are these two things the same or not? That's really hard because at the end of the day, there are a whole bunch of pixels, X many pixels. They have their RGB values or whatever. Like, how do you quantify closeness or not? What an embedding is, it's a way of taking that image and representing it like in a pretty simple way where you can do comparisons apples to apples. So the example that I show in a training that I give at Wayfair is like you can imagine taking an image and putting it on this like XY plot, and then you can put any other image on the same plot, and then you literally just measure the distance between those things, and that encodes whether or not these things look similar or not. So you could generally think of an embedding as a way of something that encodes similarity numerically, so that when it comes down to running something like visual search or shop the look or whatever it is, you can come up with this quantitative notion of, given this product, I'm going to do a stack rank of things that look like it. Where if you didn't have that way of representing it, like I don't even know how you would think about that problem.
Yeah, it's a super powerful technique that is also really popular in natural language processing. Word2Vec is an embedding model that allows you to do a similar thing with words.
Graph-based. Yeah, like graph-based embeddings are something that Pinterest has been experimenting with a lot. It allows you to understand the graph for Pinterest, for example, pinned to boards and how users collect things together. It can really represent anything. In the world of computer vision, it generally represents images or videos, and so pixels, but it can represent literally anything: text, video, image, graphs.
Yeah, LinkedIn, for example, uses it to, people are in a graph, so they can look at, where people are relative to one another and determine how similar their interests are. They put content in graphs, like articles, to determine what content is similar, stuff like that. What questions do you have for our esteemed panelist? Here? There's a mic coming.
Thanks. Question for Daniel. What percentage of your sessions or visitors actually use visual search, and how does conversion of those sessions compare to text search or browse sessions?
I'm not going to be able to answer that to a level of specificity that'll be satisfying, but I'll do my best to unless I want to get shot when I get back to Boston. Okay, so in terms of what I can say, clearly there's an upper limit to how many users are going to interact with something like visual search. So what we've seen is absolutely there's engagement. People who tend to use it tend to keep on using it. That said, our core demographic is 35 and up. And frankly, even if it's skewed younger, I don't think that people just want to do that kind of shopping experience. So there's a definite ceiling to it. In terms of how folks react when they use it, we've seen very, very clear responses when we run A/B tests. So the clearest example is after we launched the feature, we've gone through, I think, 7 iterations of the model. We run A/B tests when we do that. We track metrics like repeat visit rate. So if somebody interacts with this thing, what is their likelihood of visiting again in the next X many days? And you get very material improvements as the underlying model improves. So that part is pretty crystal clear because of the fact that you're never going to get more than half of people or whatever it is using visual search. We do a lot to figure out how do we take similar technology and maybe make it more implicit. So we use it for product recommendations where you don't have to tell us, but if you're browsing, we're trying to pull out, is there a common visual aesthetic behind what you're looking at? And then without asking you, you browse a bunch of sofas, you go to chairs, we can show you chairs that generally look similar. So we do a lot of work like that to try to find other avenues to use it.
Other questions? Over here.
I'm just a little curious on how you take speed into account of returning maybe visual search or the recommendations. So you have maybe a heavier model or more sophisticated model that might take a longer time to return a result, and how do you the engineering component of that?
I don't know if I have that much expertise in that area. So.
Yeah, so for us, it's use case dependent. So let me think. So there are things that are just generally fast. Like once you have the embedding, doing like a nearest neighbor search, like super quick. So then the question is, for those use cases, sometimes you have to generate the embedding. So like that'll be the main bottleneck. If a user submits an image, we need to make sure that we can take that image, create an embedding, and then do a relatively fast search on that. I think where it hits us more in terms of like the speed quality trade-off is on a lot of our merchandising applications, where a lot of what we do is like a very like simple example. It's not like a huge problem or anything, but we search the catalog for duplicates. And that's something where, you know, if you did it really like brute force, that's incredibly inefficient. So you have to do a whole bunch of tricks and approximations to narrow the set of things that you want to do the careful model for. We run into really similar problems on personalization, where we have these like really great models, super accurate. I can only run them on like a few hundred products at runtime. So then we need to have clever ways of taking the full catalog and sort of compressing it to stuff that's roughly in the right area before we apply the heavier stuff. So yeah, like we'll have 2-stage models pretty frequently. We'll have like different versions of the same model that has like different runtime versus accuracy numbers and that sort of thing.
It also depends on our use case as well. So something like camera search, it needs to be really fast. So like we use a more lightweight model that's faster versus recommendations. When you close up on an image, that's what we call it, gets bigger. Below that image, like it takes users time to scroll. So we have a lot of time to do like very expensive computation, whether that includes the more like graph-based embedding approach, which is actually way more expensive than like a more lightweight visual embedding. Yeah, so like in terms of product, like as long as you can have the latency be high, like do as much computational power as possible.
One more. Go ahead.
Just a couple of quick questions.
Sure.
Are you doing anything special on the model QA? I think about thousands of products and probably millions of variants, and how do you know the model is actually working? You know, how do you test it? Anything special you're doing in that area?
Yeah, or generally metrics. What metrics do you use to measure the success of these models, and how do you track those to ultimate kind of outcomes or results?
Yeah, do you want to take a first stab?
Yeah, I mean, I don't know that it's anything particularly special other than like the unique data that we have and the labels that we have, because we're doing pretty standard like keep some out for testing and training and validation purposes. And so really the uniqueness just comes down to like the rich data that we have. In terms of QA, yeah, I mean, like we have these human evaluators who are also going to not just generate training data, but like further understand exactly. And so I wouldn't say it's anything particularly novel. But
so standard supervised problems, and you're looking at AUC and that kind of
thing. Yeah, AUC, precision recall, trying to maximize those. Those generally correlate really well with online engagement. So like the click-through, if that's like what you're trying to optimize for conversions in the case of e-commerce, they correlate pretty well.
Yeah, I think for us it's pretty similar, where you have sort of like the theoretical machine learning KPI. So is recall getting better? Okay, great. Before we push stuff into production, we'll do human QA. So like literally, you know, side by side, just folks scanning thousands and thousands of results, so we can say, okay, great, recall went up. Qualitatively, it sounds like the quality of the output went up as well. And then we'll do a proper A/B experiment and try to measure more downstream customer metrics.
Also, it totally depends. The really nice thing that I've been pushing for on a lot of these models is the ability to be dynamic with like what we want for recall and precision. Because in one use case, you might want like very high recall, and the other one you want really high precision. And like the more we can allow for that knob to turn, makes it really a lot easier for the rest of the company to adopt in certain use cases.
Cool.
All right. Thank you, Daniel, Stephanie, and
That's our
Sam.
time. Cool. Thank you.